Thank you for accommodating for this time. The lectures will be recorded and live, and hopefully they will be interactive. I like to go over problems and explain things, so hopefully we'll have some good interactive sessions. For those of you, well, actually your class does not know me. My name is Professor Ruwaida Kenj, and I will be teaching you 311 this semester. هلا, let me share the screen so that I can share the slides with you. So today's lecture is going to be split into three basically sections. The first is introducing you to the course information. The second section, we're going to review, to share with you a little bit about the SPICE information, because there will be some homework assignments that are SPICE dependent, and also I will make use of this opportunity to look at one of the circuits here and give you a high-level refresher on 310. Don't feel if you forgot it, it's okay. The intent is just to bring it back to your memory. Then after that, we are going through those examples. Then we are going to go to the third part of the lecture, where we will go over the basics of the devices, the BJT, or MOSFET. We're going to start from there on the topics of the course. So we will be do revision basically. What I want to tell you is that the course depends on building your knowledge. And if anybody has a gap from 310, it is good to approach me as we review quickly these topics for office hours, or to explain to you certain concepts that you are missing, so that you can pick up one in 311. And if we are consistent, I think you should do very well, as we will go now over the information of the course. So the class will be offered Mondays and Wednesdays, 7 to 8:15 p.m. And I have posted on Moodle for you the link to the Zoom, as well as the link to the YouTube, where we will be posting the lectures. As I said, my name is Ruwaida Kenj, and the office hours will be by appointment. I am in a different time zone, so we can basically have office hours your afternoons or evenings, and I am flexible in that perspective. Okay, you can reach me by email, and we can sync up accordingly. Okay, طيب هلا a little intro on why are we studying analog design, why is it important to us? Well, the reason that I can record and send this lecture is that thanks to the analog design. So any signal that we have in life, whether it is voice, music, seismic, earth motion, any signal requires basically analog systems in order to be able to record it and save it. What happens in real life is that as we are speaking to the microphone, our voice is on very small vibrations, right? In the air, low power, very low power. And then the microphone converts the mechanical to electrical signal, and then we get some millivolts waveforms in millivolts that we need somehow to send to the system, process it, store it, maybe go through the digital signal processing unit, and then retransmit it, right? And in order to convert this small millivolt signal to have components that operate maybe at 1 volt, somehow we need to perform amplification, and then we need to quantize the signal and stuff like that. And this is where the role of the analog design comes into play. Okay, so let us see what we have here. So we said that anything that we perceive in life is analog. and the electronic devices need to interface the real world, and this happens through the analog interface. And indeed, we cannot imagine our life without analog electronics. If we look at the front end, at the receiving side, we have all these sensors, filters, analog to digital converters, and then at the back end, when we're sending the signal, we have digital to analog converters, filters, amplifiers, drivers, and many other gadgets that are needed so that we can realize this maybe evolution in converting or storing the data and transmitting it. Okay, so in this circuit, in this course, we are going to learn the basics about these circuits. Basically, we're gonna continue what you learned in 310 in terms of the amplifiers, both BJT based and MOSFET based. We're going to understand more their limitations. Yani, if I receive a signal, well, I can amplify certain frequency components, but really it is not, the amplifiers are not ideal, just like human beings, they have limited functionality. So their response decreases at certain frequencies. We need to understand how we can, what's their limitations, what's their bandwidth. We need to know how to improve their performance with feedback. We're going to talk about differential amplifiers, and towards the end of the semester, we're going to talk a little bit about digital CMOS circuit design, since the two coexist together and must interact. And of course, there will be basic SPICE simulations through the assignments. The textbook is Cedra and Smith, the 7th edition. The slides are sufficient, and we will be posting some selected problems from the book itself, and I think it should be available in the library as well. And what's the course objective? We would like to provide the students with the essential background on amplifiers, the two types, as we said, the MOS and the BJT based. We would like to analyze their characteristics, yani to be able to find what's the gain, what's the input resistance, what's the output resistance, because in 310, you learn the basic block. Here, we're going to learn the basic blocks, the remaining basic blocks, but I call it Lego building, yani Lego circuit design. If you are able to understand and abstract one block, and if you're good at looking at the graphs and you have good logical thinking, technically, the whole course can be summarized into putting the blocks together, understanding the rules, and building the bigger block or the bigger amplifier block. Yani, we're going to go through the details of explaining the different circuits, but towards the end, what we're going to really do once we explain this is to abstract each block with certain characteristics, and now see how we're going to interface or interact two blocks together. So the small signal analysis is handy up to a certain level. In the beginning, we're going to do the derivations, but then towards the end, we're going to build these sets of rules which you will be using to build the blocks of circuits together. Okay, so we will lose a little bit the dependence on this small signal analysis. We'll use it for understanding, but at the bigger picture, we'll start to use these specific rule sets. Okay, we're also going to provide for you in the class an overview of the effects of feedback on the amplifier, and towards the end we'll talk about essential background on the operation and the performance of CMOS digital circuit design families. Okay, so these are the 4 main objectives of this course. We are going to cover certain sections from the textbook, not necessarily in this specific order. Yani we're going to cover chapter 1, 2, 7, 8, 9, 10, 14, and 15, but the order will differ, and you will know the order from the set of, I will have like a problem solving sets, and we'll put what sections correspond on a regular basis. And we will update the Moodle page to tell you what corresponds to what sections. Hello. What matters most to you, I know, is the assessment, and the course assessment is divided in a way in order to be able to help you. كيف يعني to help you? Let us look at the assessment. هلا, the final exam is 40%. The exams are going to be on campus and will be common to all sections, and we are going to practice and be very ready, no worries about that. The midterm will be 35%, and we're going to talk about the details, but let us look at this. So you have around 25% within your reach that acts as a buffer or as a cushion for you to start picking your grade. Yani sometimes, and I wish that I want you all to do really well in the course, but historically, I'm saying that we have had students who did not make it, and had they submitted the homeworks or attended the short quizzes, or we'll talk about the participation component because we are online shortly, but had they submitted this, then they would have easily passed the course. So what I'm trying to say, you need to do well here, but sometimes the lack of this can hurt in some scenarios. So just guarantee this 25%. It's a good cushion, it's a good buffer for you to do well. In homeworks, try not to copy. طبعا we will give you 4 out of 5, يعني you get 2.5% on each. You'll have 4 homeworks and piece-wise assignments. You will be we will count for you the best 4 out of 5. The short quizzes, we will count the best 5 out of 6, like you've had probably in 310. What really matters, don't skip a short quiz because you did not study. I will try to look at your short quizzes. I typically grade them, look at them partially, and يعني partial, give you partial grades, and make sure that you attend a short quiz if you know the material, because you don't want to lose the 2.5%. If you've written something towards the solution, if you've done well, then you will get some portion of the grade, which matters because things eventually add up. We reserve this 1 out of 6 is in case, God forbid, somebody is sick, is absent, has an urgent appointment, because short quizzes are not repeated. يعني when we use the same policy, you miss a short quiz, you will miss it. We cannot redo the short quiz. Okay. طيب, great. And before the midterm or the final, we will have a session, a review session. We will have special sessions for you. And as far as the participation is concerned, يعني I would like to see that you are active. For example, مش إن المودل page مثلا last active 17 days ago. We never show up for the lectures where there are short quizzes. We never show up for the homeworks. We never submit anything. يعني I never hear your voice, you know, you're never for office hours and stuff like that. So this is what I mean by participation. Yeah, I will answer your question regards the short quizzes, but no, I just want you to get a feel. يعني participation, it's going to be either 0 or mid or full. Okay, 0 يعني I never heard of this person in the class, never, nothing. Mid, and okay, there is some interaction happening, and then the full means most of the time you're on time for things you're asking, you're participating in problem solving with me and stuff like that. طيب, great. هلا, you're asking me if these questions will be on Moodle or online. The short quizzes will be in like I did it last year. So it is going to be, you will write the sheet, you will scan it, and you will email it to me. Okay, and I will grade them. I will read through them, and I will read through them if you copied all the same solution or not. I really want to benefit from the short quizzes to understand where your gaps are, so that we can work on resolving them, so that you can do really well in the midterm and the final exams. Okay, so the short quiz at the end of the semester, we always do a race such that the short quizzes in all sections are 8/10 the average. Okay, so if you all get 10/10, you will all end up getting 8/10. And if you get a distributed grade or get a low grade, the average will be 8/10. So when I correct the short quizzes, I try to see feedback about what you have understood so far, especially in the first few of them before the midterm, to know where your weaknesses are. Sometimes I pinpoint you, talk to me, you have a problem with this, I need to, or talk to me during, let's sit in some office hours. So let them be some form of interaction. Don't worry about the grade. I will correct them manually and I will look through your papers and let us pick it up from there. So I know Moodle is a little bit complex for you, and I will just try to have you upload them on Moodle, and you will also send a backup by email for me, which I will save for my own purposes. But you will basically, I will be correcting the backup. Okay, so it will be interactive. We'll see how to handle the short quizzes. Okay, but mainly I will look at your scratches if this is your concern. Anybody has any other questions? The midterm will be on campus. There will be proctors. You will have the other instructors of the course there with you, so you will be with all other sections. We will sync up for this, no worries. Okay, so it will not be online. Neither the midterm nor the final. Okay, anybody has any other questions? طيب هلا بالنسبة للmonth of Ramadan, some of you also raised concerns to me that during the month of the Ramadan, or from holy month of Ramadan, the iftar will be around 7 p.m. هلا what I will end up doing during that month is I can still hold the session, record it, and then I will put a special extra session. For example, let us say if it works out for all of you on Saturdays, where I can be available for Q&A, so you can listen to the sessions and I can answer you, or I will try to send Doodle and we can figure out some time where I can be more available to your Q&As if you basically cannot attend the session during the class time. Hopefully that is okay for you. Anybody has any other questions? Okay, so the best way to study is basically both. What I encourage you to do is before the short quiz, practice the relevant questions from the book. They are straightforward, but also practice, sometimes not, but also practice the questions in the previouses, at least 3-4 previouses backwards, going backwards, that are relevant to the topic. Okay. Yes, Tana, the course will remain online until the end of the semester, but I will have flexible office hours, and we can always set appointments if you are having difficulties understanding anything or difficulty handling the material, okay? The previouses Sari are on Moodle. Thank you, Tana. The previouses are on Moodle. So if you cannot log into the Moodle page, please let me know. You should have access to it by now, and they are open. Okay, and before the midterm, the good thing about studying for the short quizzes is that it simplifies the material for you. If you collect all the material to study before the midterm, it requires time. The only thing about 311, which has been proven through time, is that you need to practice. You need to know how to use, we will give you resistor and voltage gain sheets, equivalent resistor and voltage gain sheets. I will train you on how to use them once we have learned enough. Okay, and I will walk you through example previous midterms once we have learned enough. Before the midterm, maybe we'll solve one previous, but the basic thing is that you need to have practice. لأنه getting the fact that it is open book does not help a lot. You will be lost. You cannot rely on that. You need to have seen the types. Once you have practice, I guarantee that you will do well. So make every effort that before the midterm you have at least solved 4 previous midterms, because that's the only way you will be able to maneuver through the different types of problems. And you would have seen enough that your brain now can accept the new questions and can quickly address or figure out where you need to solve these problems. So this is my advice for you. Practice is very, very important factor for 311. Okay. طيب, great. هلا anybody has any other questions? Okay. Yes, we're coming to that, Ghadi. Yeah, 1 minute. We'll talk about recitation sessions in a second. Yeah. Okay. So the midterm, it is scheduled to be on March 17, on Thursday. We'll know the time from the course coordinator. The exams will be multiple choice. Okay. And we will have the short quizzes, and it will be common to all sections of the course. We will have the short quizzes will be held on. Now, the short quizzes, I'm not monitoring you, but I count that you will not, it will be for your understanding. It will be on Monday, January 31, Monday, February 14. So the first short quiz will be next week. Okay, then we will have Monday, February 14, just like all sections, Monday, February 28. We will skip one for the midterm and we resume on March 30. And then in April, we'll have one on April 11. There are some holidays. And then we will have one on April 27. Okay. The final exam will be open book, open notes, and the midterm, I think based on previous years, it will also be open book, open notes. Okay. And the exams are objective, again, multiple choice and comprehensive and common to all sections. The assignments will be submitted on Moodle. Late submissions are accepted, but there is a penalty of 10% per day or a fraction of day. And health policy is among all the sections. طبعا, if all of you have like 4 exams during the week and we assigned it and we're not sure about this, we are flexible in that perspective. But if somebody just did not feel like submitting it, then there will be penalty. And the short quizzes will be held from your desk. Okay, and you will be uploading the answers, and the Scratch, and you will be answering it on Moodle. Okay, and I will let you put the answer on Moodle, and then you will be uploading your Scratch, and I will take a quick look at your Scratch first to get to know how you think, for the sake of you doing well on the midterm. This is very important for me. Okay, and for the final. Yes, Tala, I think the midterm is open book based on the previous policies. It's just it was not mentioned on the syllabus by the course coordinator, but I will double check that for you. But I'm sure it's going to be open book. Okay. طيب, anybody has any questions about the assessment? Thank you. Great. Let us now go to the academic misconduct. We expect highest standards of integrity in line with the AUB Student Code of Conduct. Don't copy the homework, don't copy the short quiz. Please put your own effort and your own knowledge, because it will help me guide you where your gaps are, and it will help you figure out, or at least try to think about the problem, how you should have approached it. It's all practice for the midterm and the final. Okay. You will get partials on your short quizzes. It's not either 0 or 1, it's going to be somewhere in between, and you'll get 1 definitely, أكيد. بس أنه I would like to look at your scratches and see how you think to figure out where your gaps are. Okay, and in the midterms and the final exams, very strict. Please be you, do well, help yourselves, and I will try to help you as much as I can. Okay. طيب great. If you have any issues with accessibility, feel free to reach out to the AUB Office of Education, Accessible Education Office, to let them know in case you need us to accommodate you for extra time during the exams, or especially the midterm and the final, so that we can accommodate you along that way. Okay. هلا بالنسبة للكورس, there are going to be problem solving session that will start this week. So the sessions will be Thursday 1 to 2 p.m. in Bechtel 107, Thursday 2 to 3 in Bechtel 107, and Friday 2 to 3 in Bechtel 111. Those sessions will cover the same material, and the same material is going to be repeated by the TA of the course. His name is Hani Al-Jamal. And Hani will start this week. He's a very smart and knowledgeable student, so hopefully you will benefit from his knowledge as well to help you in your learning. Okay? Anybody has any questions? Yes, yeah. Yes, Ahmed. Short quiz questions, they will be tailored to test your knowledge, like the midterm, to test your knowledge, and yes, maybe giving you an early look into what to expect in the midterm. Yeah, so you can think, and it's like a practice for the midterm. Okay, but the short quiz should be 15 minutes, not more than that, and it will be held during the time of the class, during the lecture, at the beginning of the lecture. Okay. Yes, Shushi Kojayan, yes, we can attend any one of the 3 recitations. They will be repeated sessions. Thank you. And also, if somebody has any issues with all of these 3 sessions, if a lot of you cannot attend, please send me an email so that I can notify the course coordinator. Maybe other students as well have conflicts, and we can find a session that has no conflict, a repeated session that does not conflict with any of your classes. Okay, but hopefully this should be fine for all of you. Okay, any other questions? طيب, great. Okay. This is the information for the class. Okay. If anybody still has a question and was not able to ask me, please feel free to send me an email and I can talk to you or answer you accordingly. Okay. Great. The second part of this lecture is going to be a SPICE introduction. Okay. On Moodle page, we have posted for you a sheet, a PDF sheet called lecture1spice.pdf. And this has around 7 SPICE exercises. Okay, and these 7 SPICE exercises, you can go through them slowly. I'm going to walk you in the coming 15-20 minutes through what it is going to teach you. It teaches you things on PSpice, anywhere from how you write a netlist as words, I know that you are familiar with making or building your netlists by schematics, like the picture which you see here. So you can do that, but it is intended to refresh your memory, how to build a netlist, how to simulate it, how we number the nodes, where we read the output, how we perform DC operation, how we add a diode, how we add a transistor. I'm going to walk you through these, and then, not all of them, of course, and then refresh your memory on this basic circuit, which we do a simulation for here, but it resembles what you learned or summarizes what you learned in 310, because it's a little good flashback, and then we can look at the transistor and start looking into the currents and start the course lectures. Okay, so you have this sheet. It has several exercises. Practicing some of them will help you because you will be able to maneuver or navigate in the PSpice assignments. Make sure you at least skim through this, maybe practice 1 or 2 examples and refer back to it when you are working on your homework exercises. Okay, so basically the SPICE sheet, it is a review of PSpice AD Lite, and it covers different examples from setting up the simulation, basic features of the netlist, how to do DC analysis, trends in simulation in the time domain, and then frequency response or body plots. Hello, you can use the same version you've been using for 210 and 310, and now you have access to the lab, so this should be easier for you. If you would like to download on your computer, you can try downloading version 16.6 from this link, and the link is also available on Moodle page. And for those who have Mac, you can download it from macspice.com. Okay. So SPICE is basically has an interactive graphical user interface where we can simulate and we can plot the outcome, and the netlist or the description of the circuit can be either text-based or it can be derived from the schematics. Yani either we draw the circuit or we write the circuit. Okay. Hala, if we opt to write the circuit, then we can write the circuit in a text file, and I'll show you a small example very quickly now. And typically, the first line of the text file is reserved for the name of this netlist, so the simulator ignores it. The second line, the second few lines of this text file are intended to represent the elements. يعني عندنا voltage Vn. So Vn is going to be between node 1 and 0. So this node is node 1, and this node is node 0, which is by default the ground. Okay, and then it says that I have a resistor R1 between node 1 and 2, and its value is 2 ohms. So هيدا R1 بيكون بين node 1 and node 2, and its value is 2 ohms. Okay, so we write it, or you can choose to draw it, and then you don't have to worry about labeling the nodes. And basically the last line in the netlist is a .n to tell the parser of the simulator that I finished my netlist, so I am done. Okay, طيب, great. Hala, let us see this example. So I have here the example circuit written and ready for me. Of course, you can write a new file by writing file, text, new text file. Okay, and when we want to run, we can do simulation run. Okay, and when it is done, we can ask to view the output file. And as you see here, for example, it told me that the voltage at node 1 is 10, at node 2 is 4, at node 3 is 6. So it solves for me the resistor bridge example. Okay, so let us see what also we're supposed to learn. So here, this slide just tells you what you expect to see or how to run this specific circuit. Also, SPICE allows us not only to work with passive elements like a simple resistor or a simple capacitor, we can also add nonlinear elements or more complex elements like the diodes. Hala, diodes and transistors, if you are writing the netlist, they require you to include a line starting with dot model, where you have the name of the model, my diode. Yani for example, if we're categorizing things into plants or animals or things, well, dot model plant, and then there are specific characteristics for this model, which is IS equal, which is saturation current, how much it is, and the constant N equals to 1. And anytime I want to define a diode in my circuit, anytime I want to show a diode in my circuit, I have to name the instant, for example, provide this plant, and then put the names of the nodes where this belongs, and this diode is between node 2 and 3, and then call the model name, plant. Okay, and that's it. And now I can call as many other diodes, so I can have D2 between node 4 and 5, and it will call the model my diode. Okay, and I can call as many diodes as I want. Okay. Okay, and there are command lines like .op, which show me the I current and voltage characteristics of the device and stuff like that. The exercises as they are, we are not going to go over them, but number 2 simulates the transient analysis, number 3 DC sweep, number 4 is about a MOSFET amplifier gain, 5 is a Bode plot, 6 is BJT common emitter, and 7 is the frequency response. I'm going to focus on this example because I would like to use it as a refresher for you or as a review for 310, so that when we go to the currents or the discussion of the BJT, you are of the BJT and MOSFET currents, you have like some flashback on this. Okay, so let me stop sharing, and I will. I need to share from the iPad, and let me. I need to draw this. Okay. Yeah. No. Okay, great. So let us look at this circuit here, and let us see what we have given to us. And let me draw it again for you so that you are comfortable with all these maps that are shown here. So at the core of the circuit, we have a transistor, an NMOS transistor. Okay, and the NMOS transistor has, we know it is an NMOS because there is an arrow going out of the transistor. We have a drain node, a gate node, for those of you who forgot, and a source node. And the source node sits at the arrow. Okay? And now this transistor is connected to a set of resistors. So we have a resistor RD between the drain node and VDD. Okay, and we have a resistor RS between the source node and the ground. Then connected to the gate, we have two resistors, R1 between the gate and VDD, and R2, which is between the gate and the ground. Okay, this allows me to bias my circuit well. Then I have a set of capacitors. Okay, one capacitor that is connected between the source node and the ground, and this is called CS. Another capacitor that is connected between the drain and the load resistor, RL. Okay, and this is called C2. And then I have another capacitor which is connected between the gate and the input signal Vn. Okay, and this capacitor will be called C1. Okay, now for this problem, they are asking me to find the missing elements of this circuit and to simulate the circuit afterwards in SPICE. Now, they give me a set of information. They tell me that the gain is minus 10. So the gain is VO over Vn. Okay, and VO is here around RL, the voltage across RL, and Vn is here. And then they tell me that we know the load resistor value is 47K. They tell me that we know the input resistance is 1 meg. And if you notice, these are all quantities that are related to the small signal analysis of the circuit. Again, vision small signal, our load is related to the signal load, and Rn is the effective input resistance of the amplifier. And then they tell me another piece of information which says that the DC current ID, it's a big symbol ID, so it's a DC current is 0.1 milliamp. That VDS, also DC, capital letter VDS DC is 3 volts. That the threshold voltage of the transistor is 1 volt, K prime W by L is 1 milliamp per volt square, and that VDD is 9 volts. So the missing elements are the resistors. RD, I don't know what it is, right? RS, I don't know what it is. R1 and R2, I don't know what they are. But I know that this information here is relevant for the DC analysis of the circuit. Okay, يعني IDS, VDS, and stuff like that. So I try to combine my knowledge of the small signal analysis in terms of the gain and the input resistance, and my knowledge of the DC analysis in order to figure those values of the resistors. Okay, and I'm sure you've seen this problem before, but let us see how we would do it as a refresher so that we can get a good head start. Okay, so what we are going to do first is we are going to do the DC analysis of the circuit, okay? And we will see what equations we can obtain. Now, I want to ask you a question. In DC analysis, what do we do with the capacitors?
They are presumed to have large capacitance, therefore they are replaced with open circuit.
Right. So for DC analysis, the capacitors are assumed to be open, and the frequency is 0 at DC, so they are already very large, infinite, and so we will have an open, the impedance is an open circuit, so the capacitors will be open. Okay, and then for the DC also, we keep VDD. We only do what? We only set the small signal sources to what? To 0. So a signal source would become set 0, and we will ignore Vn. So if we are going to open the capacitors, this means that this does not exist anymore. This does not exist anymore, and this does not exist anymore. Anyway, Vn, I'm gonna set it to 0. It's not connected to anything, so I'm going to remove it. R load is no longer connected to my circuit, so I'm going to remove it, right? So for my DC analysis, okay, this is how my circuit now looks like. Great. This means now that I have to build a set of equations based on the information that I have. Let's see what information do we have. We were told that ID, which flows in the drain side, and since this is a MOSFET, نحن بنعرف إنه هيدي الcurrent is 0. We were told that ID is equal to 0.1 milliamp, and in the MOSFET, the current that flows in the drain is what is the current in the source?
It's the current of the drain.
It's the same. So ID equals IS, basically, بتكفي هي ذاتها بتكون 0.1 milliamps. He also told me that VDS is 0.3 volts or 3 volts, pardon me. And he also told me that VDD is 9 volts. Okay, so VDD is 9 volts. Okay, what do I also know? I know the current, and I will need some information from Rn to solve for R1 and R2, right? But what are the KCL equations that we can solve, or the KVL equations that we can solve? هيك لنشوف. What loop I have complete here? This
We can
node
perform KCL, that governs the current path along the node,
along the
that
node
drain
G.
to the
صح،
source.
بس هون هيك لنطلع هيدي ال VDD equal 9 volts, right? The loop VDD to ground, right? So if we look at this, let me erase this little bit. Here VDD, what is it really? And this is important because I want all of you to be comfortable with it. This is really like I have a voltage source, right? Or it is a DC source actually. So I have a DC voltage source which is like this, right? So this is a plus minus 9 volt. So this is a loop, right? So anywhere I have VDD, I know that this voltage is VDD. لأنه حنجي نقول minus 9 plus RD times ID plus VDS, which is known to me, plus RS times ID is equal to 0, right? So here, we don't draw it like this anymore. Okay, you are only going to say that this is VDD, and we are going to say VDD, we take it to the other side, is equal to this quantity. So VDD is equal to RD plus VDS plus RS times ID. Okay, so this is one equation that we have. Okay, now another equation that we can learn, is this clear? Anybody has a question about this? طيب, let me see the chat here. Yes, I will post these notes on Moodle as well. Zahra, okay. طيب, great. هلا, the second equation that we have here is what? The second equation is KCL at this node. هلا, we really don't need KCL at the node. ليش؟ لأنه نحن, do you know voltage dividers? You should also be comfortable with voltage dividers a lot in this course. أمتى we identify a voltage divider? If I have two resistors where the same current is flowing in these resistors. إذا نفس الكرنت قاطع بالresistors بيكون عندي voltage divider. هلا, in this circuit, if this is I1, I2 is equal to I1. ليش? By virtue of what?
Because IG equal to 0.
Right, so we have I1 by KCL. I1 is equal to I2 plus 0 اللي هي IG وهيدي هي 0. Okay, so once the same current now flows in these two resistors, this means that I will have a voltage divider, and instead of having to solve many equations, I know that VG is equal to what? R2 over R2 plus R1 times what? Times VDD. Okay, times VDD. Okay, so therefore the voltage divider tells me that anytime I have two resistors where the same current is flowing in them, if this is VDD, this is where G is around R2, بتطلع VG هي R2 على R2 plus R1 times VDD. So these are the two equations that I can get from DC. With this information, I cannot find the resistors yet. Okay? But I want to make sure that this refreshed back for you the how we build the DC circuit. This refreshed back to you how we open the capacitors, what KVL is, and how we do voltage division and stuff like that. Okay? Great. Anybody has any question? هلا, we're going to look at the small signal analysis. هلا, the small signal analysis, what happens? The capacitors
Replaced by
become
short circuit.
ليه؟ لأن أنا عندي 1 على J omega C, right? If this is C infinity, so long that the frequency is non-zero, this is going to tend to what? To 0. So it is going to be short. لهيك you will see a lot in the midterms we put infinity of the capacitor. يعني هيدا بالسمول signal analysis it will be shorted. هلا نفس الشيء DC signals بهالحالة we are going to set them to 0. يعني VDD will be shorted to where? To ground. If I have a DC current source, this will become what? Open. لأنه zero current source means it is open. فإذا the DC signals will be set to 0. Okay, and the capacitors are shorted. Now we are going to look at the figure again. Let's go to the top figure and see what happens to it. Let me sketch it quickly so that we can see what happens to the figure. So we said we have here the transistor GDS, okay, and then we had the resistors, okay, this is RD, this was VDD, RS, this is the ground, R1, R2, okay, and then we had the capacitors that connected us here, a capacitor, here another capacitor, here another capacitor, and then we had the R load, and we had the VN, okay? Okay, so let's see what happens here. So we agreed that first the capacitors are going to be shorted. يعني هيدا حيصير عنا إياه short. What happens here when this is shorted? This node becomes what? 0. Right? So شو بيصير بالresistor RS بالsmall signal? What happens to RS in the small
It's
signal?
removed.
It is removed, it's bypassed, right? The current will flow in the short, it will not flow in the resistance, so we're gonna remove this. So practically speaking, this node is going to be grounded, right? Okay, now this capacitor also is going to be shorted, يعني أنا صار اللود now is connected to my node. This capacitor will also be shorted, so the input signal is connected to the gate. VDD will become grounded. VDD will become grounded, right? What happens to these two resistors, R1 and R2? R2 is between G and the ground, and R1 is between G and the ground. What are these? Can I
They are
combine
parallel.
them? So we can combine them. So I'm going to remove this, and I will say here now I have R1 parallel R2 here. Okay, now this is my reduced circuit for the small signal analysis. Okay, so this is my circuit for the small signal analysis. Now I can work with it and build my small signal analysis. Okay, type great. What is this amplifier? What type of amplifier is this?
Common source amplifier.
common source لأنه هيدي السورس نود هي موصولة على ground. رح نرجع نراجع we're gonna review it this semester. Okay, now let me, since we're going to talk about the hybrid pi models, let me give you a refresher. هلا ب 311 we're going to put formula sheets for this. The moment you see a common source amplifier, you will be able to derive its gain. But in the beginning, we're going to go back to the hybrid pi model. Let me share with you the hybrid pi model. Great. هيدي D, S, and G. هيدا الهybrid pi model. G, S, D. Okay. I have a current source whose value is the GMVGS. And I have a resistor RO, and here is the small signal voltage VGS. Okay, let me just see if I can cut this to move it a little bit. Okay. Okay, great. Right. This is my transistor. Now, any circuit we want to analyze with a small signal, we have to plug it in. Okay, let's see. Start with the simplest node. Node S, what is connected to it?
The ground.
Ground, element by element. تعال هات لنشوف يلا. Element 2, RD, where is it connected? Between what node and what node?
between the
RD
drain and the
and the ground for
and
the
the ground.
source node, right? كل هو ground صح؟ يعني فينا نوصلها بهاي, right? So this is RD. Let me put it in the same color حتى تكونوا مرتاحين فيها. Yeah. So basically this node is ground and we have RD between the drain and ground, right? RL, where is it connected to? Between what node and what node? RL. هيدا
نفس الشيء.
كمان RL بين الدرين والground, right? Okay, let us ignore a little bit RO in this example. Okay, so this is between the drain and ground. Pardon me, let me fix the drawing here. Okay, so this is between the drain and the ground. Great. طيب شو عندنا بعد عندنا الانبوت resistance اللي هو R1 parallel R2 between what node and what node R1 and R2 are gate and
the ground.
ground, right? So between the gate and the ground, هو كلهم ground, صح? And what about Vn? It is between the gate node and the ground. So Vn is also between the gate node and the ground, which happens to be the source node in this example. So basically أنا عندي هون فيني أشيل الجراوند, هيدول الريزستور فيني أجمعهم. I can say that this is RD parallel ل RL. It's between the drain and the source node, which is ground. This here I have R1 parallel ل R2, which is between the gate and the ground, and this is Vn, right? So, anybody has any questions about how we obtained this circuit on the right from the circuit on the left? حدا عنده سؤال? Okay, let me see the chat box here. Okay. طيب, great. Now that we have, thank you. Now that we have this circuit, we can figure out what's the gain, what's the input resistance, صح? The input resistance is the resistance seen by the input signal. Hone, it is simple, and we will learn how to derive the input resistance later. What is the resistance seen by the input signal?
R1
It's R1 parallel R2.
Right, so it is R1 parallel R2. Okay, great, excellent. And we will talk about it more as the circuits become complex. بس هيدي بس هيك refresher. What about the gain, which is VO over Vn? This is the
It's
output
minus
voltage. When
G
output
sub N
voltage?
are equivalent.
صح, when output voltage VO? VO, هات لنشوف نكتبها هون. VO is equal to minus GM VGS times what? RD parallel RL. ليش? What loop do I look at to solve for VO?
It's from D to ground, so the current is downwards, where that's why you put the minus.
So the current exactly that is flowing in the resistor is the same as the current in this loop اللي هو going down here. But in the resistor, it is going up, right? And because it is going up in the resistor, then we need to put the minus لأنه the opposite current is going into VO, and therefore minus GM VGS times RD parallel RL, right? Okay, type this is VO, so this ratio is equal minus GM VGS times RD parallel RL. And let us now look at what is VGS or what is Vn? What is Vn? هيدا هو بين هالتو نودز. شو مسميينهم نحن الفولتج across these two nodes؟
VGS.
VGS. It falls exactly between the two nodes of VGS. So Vn is equal to VGS. They are it's a parallel branch, right? It's equal to VGS, and therefore now I can cancel VGS from both, and I will obtain the gain minus GM RD parallel to RL. So now I have that, I know that the gain is minus GM RD parallel LRL. Okay, so the small signal analysis gave me two pieces of information. Number one, what is Rn as function of R1 and R2? And number two, it gave me another piece of information, which is what is the gain in terms of the circuit elements. Okay, great. Hella, let's look at what we have. For R1 and R2, I have equation number 1. And I have equation number 2. So hopefully I can construct two equations, two unknowns, to figure out what R2 and R1 are. And from the gain, as we will see on the slides briefly next, since we want to go into the basic material, we don't want to dig deep into this, that RD, I can obtain it from the gain. And once I have RD, I can use this equation to solve for RS, and we have this info on the slides. Okay, so I'm going to stop sharing here and we'll go back to the slides now. And let us pick up from here. Okay, so هيدي it is meant best to be a refresher لأنه هلا حنرجع نبلش بالبasics. We're going to start with the basics of the transistor current and the hybrid pi model. And I did not want to talk abstract to you. I just wanted you to refresh back where we will be using this. طيب great. هلا here what we are saying now is that while we are going to design the amplifier for this, with this gain, here are the parameters for the amplifier that we have, and assuming that the capacitors are very large, this means that at the operating frequency they will have small impedance, and we're going to short them in the small signal analysis. Here we are talking about the relations that we obtain in DC analysis. We're going to open these, we're going to obtain this relation. We rely on this information equal to 0, the KVL, in order to solve for the problem. Okay, and then we will have the small signal analysis as well as function of the parameters of the circuits to solve for RD. So we will need to know the equation of the gain, and we need to find the GM parameter from the current. We'll talk about this later in the lecture, and we can then solve for RD. We will perform the DC analysis. From it, we can find RS. From the current, we can figure out what is the overdrive voltage. We're going to talk about it now. Don't worry, we'll refresh your memory about this. Once we find it, we can find VG. From VG, the voltage divider. We will have one equation for R1, R2. And from Rn, we will have another equation for R1, R2. For now, two equations, two unknowns. We can solve for R1 and R2. Hala, the most important takeaway from this problem for me is that you are able to refresh back and okay, for DC, what we do, for small signal, what we do, that we can have sets of equations to solve the problems under at hand. Okay, أنا عشان هلا في بالأخير بدنا نرجع, we want to review the basics and then we will solve such types of problems, but I just wanted you to get some basic knowledge. هلا, in terms of the net list, and I'm going to show you a small net list briefly, and then we will start with part 3. In terms of the net list, basically we can talk about an input signal which is sinusoidal. So this is the name of the signal, node 1, node 2, and then the sine function. This is the frequency, and this is the amplitude. We will need to call a MOSFET model. The MOSFET starts with M, its name. Rueda starts with I. The MOSFET can be M1, M2, M3, M10, M100, M my MOSFET. وهم يبلش بM. Then the node order is drain, gate, source, and body. So this MOSFET basically is between the drain at node 4, the gate is at node 3, the source is at node 5, and the body is connected to it at node 5. We have a name for the model, like we call the my model. This is an enhancement MOSFET. So we have a model line that specifies its name, like plant, animal, or thing. And here is the instance name. Okay, for GM, we're going to talk about the GM, how we derive it from ID. I had a question now on the chat. So let us talk about it shortly. If ID is given Tariq, we can derive it from the equations or vice versa. Okay, now in the MOSFET model here, we are going to define K, we are going to define VT, and we are going to define lambda, and we are going to review all of these very shortly. Don't worry about remembering them now. And then we can plot the gain of the circuit and output the bias point, output the characteristics of the amplifier in the simulation and stuff like that. So let me show you quickly an example circuit. Okay, and then we will show the plot. And once we see the plot, we're going to go and start the basics of the course. Okay, so this is exercise number 4, sorry, and in exercise number 4, I happen to have the circuit here, and let me close this so it will open again. Yeah. So we're gonna open the circuit, and we are going to see one example run. So here we define VDD, we define the input, we define the capacitors, and we defined the resistors, and we asked for a transient simulation, and we're going to run this circuit. And if we do trace, add a trace, for example, here I'm going to add a trace, but I already have it. For example, V of 1 or V of 6 for the output, V of 1 for the input. Okay, so it is showing me others. I'm going now to delete all the traces, and I'm going to add another trace, V of 4. Okay, so you can see here a weak sinusoidal signal. These are intermediate nodes. I'm going to add V of 2, and basically let me see the netlist to know which node the output was at. So here the input is at node 2, and the output is, the load is at node 6. So we're going to come back here. Let me delete all traces and plot node 2 and node 6 for you here, and we will look at how the gain shows. Okay, so we're going to add a trace for node 2, and this is the input. You can see it is 1 millivolt amplitude, and then we're going to add a trace for node 6, which is the output, and you can see now that the output is around 10 millivolt, but it is inverted because the gain is inverted, and it is around 10x the gain for this circuit. Okay, so here this was an example for simulating an amplifier circuit. Okay, the remaining sets of the slides talk about the Laplacian. They summarize basically the PDF, key commands in color, and then they talk how to include a BJT, how to include the model for the BJT, how to include a library for advanced models, and how to perform the frequency simulation. And they elaborate on the specific commands that are more highlighted in the, more explained in the paper. Okay, so anybody has any questions about this part? Okay, طيب هلا we're gonna start. So this was supposed to be an intro. I'm going to start in the remaining 10 minutes or 8 minutes to talk about the part 1 lectures. Okay, so on Moodle we have part 1, and in part 1 we're going to do a review on the MOSFET and the BJT currents, and then we are going to introduce a new topic, which is the current mirror. The reason why I want to go through this is because it will still rhyme with what you have seen, and it will refresh back a little bit your memory. Okay, so here we have in this picture an NMOS device. It is characterized by its drain current ID. We have the gate, drain, and source nodes. Okay. And for purposes of amplification, we are going to be interested in the MOSFET as an amplifier. We want the MOSFET to be in the saturation region. يعني if you recall the current characteristics, the ID versus VDS characteristics of the MOSFET, it used to have a linear region and then the current saturates. So the current saturates, we are interested in the saturation region. This would represent VGS1. This for us represents another value for VGS2. Okay, for it to be in the saturation region, we have to satisfy two criteria. The first criteria is that the MOSFET is on, meaning VGS is greater than VT. And the second criteria is that VDS is large enough. يعني VDS is on the larger side, to the right of the curve, because we want VDS to be greater than VGS minus VT, or the overdrive voltage. يعني هون إذا ال VGS 1 volt, if we assume that VT is 0.3 volts, I want to have VDS greater than 0.7. Okay, so we want VDS to be larger than the overdrive voltage. Here we will have another value dependent on what the operating VGS is. Okay, فإذا there are two requirements, VGS greater than VT and VDS greater than VOV. هلا, in parallel with this, the BJT also has 3 nodes, اللي هن البيس, الcollector, and the emitter nodes. And here we are showing the NPN, يعني هاي دي NPN, okay? And the way we know it is that the arrow is going outward, مثل الأنموس, the arrow is going outward, هون in the direction of the PN junction. And for this transistor to satisfy the amplification requirement, we want it to be in the active mode. And for it to be in the active mode, there are also two requirements. هيدول two requirements are as follows. The first requirement is that the transistor is on, يعني VBE, PN junction is forward biased. It's greater than VBE only, he typically 0.7 volts. Okay, and we also want VCE, okay, مثل كيف قلنا VDS, to be greater than VCE edge offset. So we want this to be large. Typically we look at a value which is greater than 0.3 volts. All requirements like on a circuit or the transistor is in active, and we can use it for purposes of amplification. Okay. طيب هيدي it is basic knowledge. Okay. Anybody has any questions? Yes, let's see. Okay, thank you. Okay. طيب هلا these transistors have their own characteristics. يعني we need, in order to solve for the gain, for the parameters of the pi model, we need to know the characteristics of the circuit. The MOSFET, when it is in saturation, as we agreed, whether it is in saturation or not, always IG equals to 0. Okay, we remain with ID, and the same current in the drain flows in the source, okay, in the MOSFET, and the current in saturation is half K prime W by L times VOV squared. This is the equation that you learned. VOV is VGS minus VT, and K prime is mu N times Cox. Okay, so this is the equation that we need to remember. Let's see what they give us here. In some cases, as you recall, typically the current, it saturates when VDS is large. Sometimes there is weak linear dependence on VDS, يعني it grows slowly, and this weak linear dependence is portrayed in the 1 plus VDS over VA component, where VA is a very large voltage for this slope to be very small. Sometimes we used to write this as 1 plus lambda times VDS, where lambda is very small and it represents the slope. Okay, so this component or part of the equation is meant to represent the slight linear dependence on VDS, and we refer to it as the channel length modulation. هلا, in most scenarios in 311, we will consider the channel length modulation only to calculate the parameter little r0, which we use for the small signal analysis, and we will ignore it in our DC analysis. Yani if we are solving for a DC current, we are going to assume that I is half K prime W by L V of V squared. Okay? طيب, great. In a similar fashion, okay, حكينا عن ال K prime in mu and C ox, and there is one more piece of information, and VA is dependent on a constant and the length of the device. يعني we can derive it from this property because it depends on the length of the device. هلا, in parallel to this, the BJT will be in active mode. The BJT, we have it here having current, it has a current IB, okay, but it is not zero, okay, and it has a current IC and it has a current IE that are different, okay, because IE is equal to IB plus IC in the BJT. This is the difference between the BJT and the MOSFET, okay? And here are the equations for the BJT. Okay, so these are the equations for the BJT. IC of the BJT is equal to IS, it's a constant, times e to the VBE, هيدي ال VBE هون, over VT. VT is also a temperature dependent constant voltage, 25 millivolts. And IB is nothing but IC over beta. And then we have the equation that says IB plus IC equal IE. So this means that IC تطلع معنا تساوي beta على beta plus 1 times IE اللي هي alpha times IE. Okay, so these are the current characteristics of the BJT. And also the BJT can have an early voltage component or a small linearity in the active region. Now, however, عند the hybrid pi model, we went over it already. Below frequency analysis, the above equations, LDC analysis equations, and here we will have the small signal model. Okay, for the MOSFET, there is no current flowing into the basic circuit of the transistor, and the current flowing from the drain to the source is GNVGS. Sometimes we have a resistor RO in parallel with this current, and this quantity and this quantity, we're gonna go over them. We'll see how we derive them from the small signal characteristics. Okay, next time we will resume from here. We will talk about the pi model parameters, and then start introducing